Today we're going to be talking about some applications of systems of equations. And make sure that you're writing this entire example down, including the words. If you don't write down the words, that's not going to help you when you get to a problem similar to this, because you're not going to know where you got the equations from. Tickets for your school's play are $3 for students and $5 for non-students. On opening night, 937 tickets are sold, and a total of $3,943 is collected. How many tickets were sold to students and how many tickets to non-students? So the key thing pretty much with every word problem we're going to do is define your variables. That's the first thing I'm going to be always looking for. But your variables are going to answer the question. Okay, so how many tickets were sold to students? So X is going to be students, and Y is going to be non-students. Now, what you need to keep in mind, the best advice I got in high school when working on applications is that you need to realize that the number of variables you have is the number of equations you need to have. I have two variables. I need to come up with two equations. So our first equation, 937 tickets are sold. So the number of students plus the number of non-students equals 937. Now let's talk about the money we brought in. There's money. Okay, how much for a student? $3 times the number of students, $5 times the number of students, so 3x plus 5y is going to equal 3943. Now you have this system of equations. Since one of your coefficients, technically both of the coefficients on the x and y here, are both 1, it's going to be easiest to solve this by substitution. So if I take this equation and I'm going to solve for y, and I'm going to plug into our other equation, the y goes away. It's this new thing. This new thing is this 937 minus x. Now it's just a matter of simplifying and solving. 5 times 937, 4685 minus 5x is going to equal 3,943. Simplifying, I get negative 2x equal to negative 742. So x is going to be equal to 371. And I did a lot of that work on my calculator, and I was just looking at my notes, so make sure you guys realize that. So tell me, 371 is standing for student tickets. So 371 is the number of students that attended. Now you can plug this 371 into any one of these three equations. This one, or this manipulated one to solve for y. This manipulated one makes the most sense. So I solve for y, I get 937 minus x, which we found was 371. So that turns out to be 566, and that's the number of non-students. Okay, so that's our first example. I call this the ticket type, where you're selling tickets, you're selling a certain amount of things, and there's a price. This next example is a mixture problem. Okay, so in this example, Denise owns a car that runs on a mixture of gasoline and ethanol. She buys fuels that have 85% ethanol or 25% ethanol. How much of each type of fuel should she buy if she wants to fill her 20-gallon tank with a mixture of fuel that contains 50% ethanol? And again, make sure you're writing out this entire paragraph. So, and label it mixture problem so that you know when you come to a mixture problem, you set everything up the same way. in this one, set up a chart. Okay, you're going to have a chart here. And I probably always overestimate or sometimes underestimate how big my chart needs to be. Okay. So there is a few things we need to first do. First thing we need to do, I was just a very bad math teacher. First we need to set up our variables. Okay, so how much of each type of fuel? So X is going to be our 85% and Y is going to be our 25%. Always set up those variables. That's something I'm going to be looking for in every word problem. Okay, so in this, I knew I overestimated. I just looked at my notes. I need to have another column here because that other column is going to help us. Okay, across the top, in any mixture problem, put the two amounts that you have, the 85%, the 25%, and then label this total. And then down here, you're going to have the amount. And then you're going to talk about the percentages of each. Okay, so 85. What's the amount of 85? That's our X. The amount of 25 is our Y. What's the total amount? Go back to your word problem. How many of each type of fuel should she buy if she wants to fill her 20-gallon tank? So the amount of 85 plus the amount of 25 has to equal 20. And then the percentages. So she needs a 50% ethanol fuel. So she has one that's 85. 85% of these gallons are ethanol. 25% of the Y gallons are ethanol. Now to figure out the total amount in our percentage here, we have 50% of our 20 gallons. So really now we have two equations. We have X plus Y equals 20, and we have 0.85X plus 0.25Y is equal to 10. Now again, this one, I personally think it's easiest if we solve this top equation for one of our variables. So solving for Y, we get 20 minus X. You could multiply each one of these terms by 100 to get rid of those decimals, or you could just work with the decimals. In my notes, I think I went the harder, not smarter way. I kept my decimals, so I'm going to keep my decimals. 0.85X plus 0.25Y is equal to 10. Again, remember I got 10 by doing multiplying 0.5 by 20. Substituting in my 20 minus X. Now it's just a matter of simplifying. Okay, let's look at what I got here. 0.85X plus 0.25 times 20, which is 5, minus 0.25X is equal to 10. 0.85 minus 0.25, that's 0.6. If I subtract that 5 over, we get 5. When I divide, I get 8.3 repeating. I don't want just 8.3. I either want 8.3 repeating, 8 1/3, I don't know why that decimal place there, or this is an improper fraction. Improper fractions, usually one of my answers is that in these word problems that's not as huge of a deal, which would be 25/4. So we want, now tell me what this is standing for. We need 8 1/3 gallons, give me a label, give me a unit, of our 85%. Now I've found that this is 8 1/3, so I have 20 minus 8 1/3 to solve for the 25. I again use this equation to solve for my 25. I did that and I got 11 2/3. So then we have 11 2/3 gallons of our 25%. So that's a mixture problem. Again, set up this chart and fill in what you know. When you come and ask me for a question on these, I'm going to say, did you set up your chart? Show me your chart. That's the first thing I'm going to ask for, because not every question is exactly like this. But if you set up your chart and you're able to fill it in, that's going to help you. Okay, our last example, I call this a current or application, or I'm sorry, current or airplane application problem. So if you were talking about the current of a river and a boat, or a current of a river and a swimmer and an airplane, these are all the same type of problem. So with a tailwind, a light plane can fly 720 kilometers in 2 hours. Going against the wind, the plane can fly the same direction in 3 hours. What are the wind speed and airspeed of the plane? Again, set up your variables to answer the question. Wind speed, let's be unique and name it W. Wind speed, and let's name A airspeed. This all goes off the concept of distance equals rate times time. So that's what our chart is going to be. And again, I'm going to tell you guys to set up your chart. And we have two possibilities. We have with the wind, and we have against the wind. So let's look at this first piece. With a tailwind, the plane can fly 720 kilometers. That's our distance in 2 hours. So with a tailwind means the wind is at the back of the plane, and it is helping the plane along. So think about a windy day, or think about you're on a boat in a river. If the current is at your back, pushing you forward, the wind is at your back, pushing you forward. You're on a plane, it's at the back, pushing you forward. The airspeed is being helped by the wind, so it's A plus W. Now against the wind, we have 720, and it's going to go this same distance in 3 hours. Let me actually do this in a different color. So 720 in 3 hours, but in this case, our airspeed is being taken away from the wind. When you walk into the wind is hurting how fast you can walk. If you're paddling upstream, it is the currents coming at the front of your boat, I believe it's called the bow, coming at the bow of your boat, you're trying to paddle, it's making you have to paddle faster to try and go a certain distance. So your airspeed is being hindered by the wind speed. So our distance equals time times rate. Distance equals rate times time. Distance, 720, equals our rate, which is A minus W, times time. Now I wrote that a certain way, because there's a trick to solving these. This trick is, as long as 2, this number that's in front of the parentheses, goes into 720, you can divide by that number, because that cancels that 2 out on the right side. So I get 360 is equal to A plus W. Here, if I divide out a 3, the 3's cancel, and I end up with 240 equals A minus W. Now look at this. This is so cool. Of course, remember, I'm a math geek. When you add those two equations together, the W's cancel. What you do have to remember is to add the left side, add the right side. A plus A is 2A. A lot of students will just put A there, and that's a common mistake. Divide, and we get 300. So label what we just found. Our airspeed is 300 kilometers in 2 hours. Our wind speed. Now we have to find the wind speed. What I recommend you do is look at these revised, once I've divided out, equations. And I have one here that makes our life really easy. 360 equals our airspeed plus the wind speed. 360 equals our airspeed, which is 300, plus the wind speed. So when we subtract, we get 60 for our wind speed. So we have 60 kilometers per hour for our wind speed. Something I forgot to talk about. There's a reason that I always put this as A minus W, because typically airspeed is going to be more than the wind speed. If you did W minus A, then we'd have a negative number here, and that wouldn't make sense. So typically airspeed, or the rate you can paddle on a boat, is faster than what the current or the wind is. So make sure you're always putting the larger one first, which is airspeed minus wind. Okay, please make sure you fill in the Google form that is below this video on Schoology on time.